There are now nearly 2 million AI models in the world. You've heard of maybe 6 of them. Today we're going to talk about what they actually are, why there are so many, how to choose one, and more importantly, why some cost 420 times more than others. No jargon, no textbook, just the things that are actually useful to know. Let's start at the beginning. What is an AI model? Here's the simplest way I can put it. Imagine someone who has read every book, article, forum post, and website ever published, billions of them, over a period of years. They never went outside. They didn't experience the world, but they absorbed so many patterns of language and thought that when you ask them a question, they can respond in a way that sounds deeply informed. That's roughly what a language model is. It was trained on an enormous amount of text, and it learned to recognize patterns in how sentences work, how ideas connect, how questions tend to be answered. When you send it a message, it's not looking anything up. It's generating a response based on everything it absorbed during training. Think of it less like a search engine and more like a very well-read friend. The search engine fetches documents. The model generates responses from memory. Those are fundamentally different things, and the difference matters when you're deciding what to use one for. One important caveat: that well-read friend graduated at a specific point in time and then stopped learning. They know everything up until their training cutoff. After that, they're guessing or saying they don't know, unless you tell them yourself. And one thing that will be relevant later: they can sometimes sound completely confident while being completely wrong, because they're pattern matching, not fact-checking, something to keep in mind. So why nearly 2 million models? There are 4 main reasons. First, different companies, different philosophies. OpenAI, Google, Anthropic, Meta, Mistral, XAI. They all have different goals, different safety approaches, different ideas about what an AI assistant should do and how it should behave. They're like car brands. They all make vehicles. But a Tesla and a Land Rover aren't competing for the same buyer. Second, specialization. A general-purpose model is a Swiss Army knife. Occasionally, you want a scalpel. Models get trained, or fine-tuned, which is a kind of specialist boot camp, for specific tasks: legal document analysis, medical diagnosis, writing code, customer service in a specific language. Sometimes a specialist model that's smaller and cheaper will outperform a much larger general model on its specific task. Third, open source. Meta's Llama model is free to download and run on your own hardware. The OpenAI API is a paid service you access over the internet. When a model is open source, anyone can take it, modify it, and release their own version. The open source ecosystem on platforms like Hugging Face has spawned hundreds of thousands of variants, which is most of those 2 million. Fourth, the size-speed trade-off. Bigger models are generally smarter, but they're slower and more expensive to run. Smaller models are faster and cheaper, but less capable. Every major AI provider now offers a family of models. A fast, cheap option for everyday tasks and a large, powerful option for when you actually need it. That doubles or triples the number of models per company before anyone else adds anything. The names most people actually use? There are about a dozen. The rest are variants, experiments, specialized tools, and research models. The landscape looks overwhelming. The practical options are actually pretty manageable. Since they'll keep coming up, here's a quick tour of who's who. GPT, OpenAI. The household name that started the current wave. ChatGPT put AI assistants on the map for mainstream audiences. OpenAI's models range from extremely cheap to extremely powerful, and they're what most people picture when they think AI. Claude, Anthropic. Known for long, thoughtful conversations and a strong emphasis on safety. If GPT is the fast-talking consultant, Claude tends to be the careful one who reads the whole document before answering. Gemini, Google. Deeply integrated with Google's products. If you use Google Workspace, you'll encounter Gemini. It's also notable for having some of the longest context windows available, which matters for large documents. Llama, Meta. Open source and free to run yourself. If you want to self-host your AI with full control over your data, Llama is where most people start. Asterisk, asterisk. DeepSeek, asterisk, asterisk. A Chinese lab that caused something of an industry panic in early 2025 by releasing models that matched much larger competitors at a fraction of the price. They changed what people expected from the economics of AI. Asterisk, asterisk, Grok, XAI. Elon Musk's model, integrated with X. It has access to real-time data from the platform, which differentiates it from models with fixed training cutoffs. Different models for different situations. And if you're using an app that's powered by AI, the model has usually been chosen for you. You might never need to think about this at all. So when do you need to choose and how? The honest answer is, it depends on the job. But here are the factors that actually matter. Asterisk, asterisk. What kind of task is it? Casual conversation, creative writing, coding, and data analysis are all quite different problems. Some models are noticeably better at specific tasks. Asterisk, asterisk. How fast does it need to be? A real-time voice assistant needs near-instant responses. A research summary that runs in the background can afford to take a few seconds. Asterisk, asterisk. What about privacy? When you use a hosted model via API, your text is sent to that company's servers. For personal use, that's usually fine. For confidential business documents, it might not be. Self-hosted open-source models keep your data entirely on your own hardware. Asterisk, asterisk. What does it cost? We'll get into the specifics shortly, but cost scales with usage. It matters a lot more at volume than for occasional personal use. Asterisk, asterisk. How much can it hold in memory at once? We'll get to this too. The short version. Some models can handle entire books, others lose track after a few thousand words. Asterisk, asterisk. How good does it actually need to be? This is the one most people skip, and it's the most important. For the vast majority of everyday tasks, summarizing an email, drafting a reply, answering a factual question, a cheap, fast model is more than sufficient. Reaching for the most powerful model by default is like hiring a neurosurgeon to put on a Band-Aid. It'll do it perfectly. It's also completely unnecessary. The practical advice for most people: start with the free tier of whatever assistant you're already using. It's probably good enough. If you hit a specific limitation, it can't handle long documents, it struggles with code, it keeps getting something wrong, that's when you shop around. Now for the question everyone eventually asks: why is there a 420 times price difference between the cheapest and most expensive models from the same company? Three things drive cost. Asterisk, asterisk, training cost, dot, asterisk, asterisk. Building a frontier model from scratch costs hundreds of millions of dollars, sometimes more. GPT-4's training run reportedly cost over $100 million. That investment has to be recouped somehow, and the flagship models carry a premium partly because they represent the cutting edge of what that investment produced. Asterisk, asterisk, model size, dot, asterisk, asterisk. Inside every AI model, there's a number called parameters, roughly the decision knobs that the model uses to process and generate text. A model with 70 billion parameters uses far more computing power per response than a model with 7 billion. More parameters generally means more nuanced reasoning, but it also means more hardware, more electricity, more cost per query. Asterisk, asterisk, running cost, dot, asterisk, asterisk. Every time you send a message, the model processes it on specialized hardware, GPUs that cost tens of thousands of dollars each. Popular models serve millions of queries every day. That's an enormous ongoing electricity and infrastructure bill. The pricing you pay per query reflects that reality. A useful mental model, the cheap option is the food truck. Fast, affordable, does the basics brilliantly. The expensive option is the Michelin star restaurant with a brigade of chefs. Both serve food. The quality difference is real. But for Tuesday lunch, the food truck is fine. One genuinely good piece of news. Prices have been falling dramatically. What cost $15 per million tokens 18 months ago now costs around $3. DeepSeek's models, competitive with much more expensive Western alternatives, accelerated this trend significantly. The economics of AI are improving fast, and the gap between affordable and powerful is narrowing. Which brings us to tokens. What are they, and why do they keep appearing in pricing tables? A token is the basic unit that AI models use to process text. Not quite words, not quite letters, something in between. In English, a token is roughly 3/4 of a word. 100 tokens is around 75 words, a short paragraph. 1,000 tokens is roughly a 2-page essay. An average novel is around 130,000 tokens. Why not just use words? Because models also handle punctuation, partial words, numbers, code, and multiple languages. Subword chunks let the model handle all of that more efficiently than whole word units would. Here's why tokens matter for cost. You pay for both the tokens you send and the tokens you receive back. The message you type is input tokens. The AI's response is output tokens. If you paste in a long document before asking your question, you're paying for every word of that document in addition to your question. If you ask for a detailed essay, you're paying for every word of the response. Think of it like a taxi that charges by the meter, not the kilometer. Tokens are the meters. The longer your journey, or the more you've packed into the car, the more it costs. This is also why AI assistants sometimes seem to forget things from earlier in a long conversation. They're not being rude. They're working within a limit on how much they can hold in memory at once. When a conversation gets long enough, older messages get trimmed to keep costs and processing time manageable. That limit has a name: the context window. The context window is the maximum number of tokens a model can see at once, its working memory. Everything that fits in the window is visible to the model when it generates its next response. Everything outside it is gone from the model's perspective. Early models had context windows of around 4,000 tokens, enough for a few back-and-forth exchanges. Modern models typically offer 128,000 to 1,000,000 tokens or more. That's enough to hold an entire book. A big context window matters when you're working with long documents, extended conversations, or complex projects that require a lot of background information. A small context window is perfectly fine for quick questions and short tasks, and those models are usually faster and cheaper. If you've ever had an AI assistant suddenly seem to forget your name or the context of what you were building together after a long session, that's the context window filling up. It's not personal, it just ran out of desk space. Let's make this concrete with some real numbers from March 2026. Prices are listed in dollars per million tokens, which sounds like a lot, but most individual queries use only a few hundred tokens. This is really relevant at scale or when you're comparing options. At the cheap end, GPT-5 Nano charges 5 cents per million input tokens. DeepSeek V3 is 28 cents. These are genuinely capable models for most everyday tasks. In the mid-range, GPT-5 Mini at 25 cents input, Claude Sonnet at $3, Gemini Flash at 50 cents. At the top, GPT 5.2 Pro at $21 per million input tokens and $168 per million output tokens. That's the 420 times gap from the same company. GPT-5 Nano versus GPT 5.2 Pro. To put that in perspective, processing an entire novel through DeepSeek costs about 4 cents. The same task through GPT 5.2 Pro costs around $2.70. For personal use, even the expensive models add up slowly. Most people's AI usage costs a few dollars a month at most. At scale, for applications serving thousands of users, the choice of model has massive financial implications. So here's the practical summary. An AI model is a pattern recognition system trained on enormous amounts of text. It generates responses. It doesn't look things up. It's confident by design, which means you should verify anything important. There are millions of models because there are many companies, many use cases, many size-speed trade-offs, and an active open-source community. In practice, a dozen models account for most real-world usage. Choosing a model comes down to task type, speed, privacy, cost, and, honestly, how much quality you actually need. Most tasks don't need the best model available. Cost is driven by training investment, model size, and the hardware required to run it. Prices are falling fast. The gap between affordable and capable is narrowing every few months. Tokens are the unit of measurement, input and output. The context window is the model's working memory. Bigger windows can handle more, but every token has a cost. And the most useful thing I can leave you with, don't over-engineer your model choice. Start with what's free and convenient. Upgrade when you hit a real limitation. The best model is the one that does the job without burning your budget or your patience, which, honestly, is good advice for most things in life. You now understand what models are, how they're priced, and how to think about choosing one. Next episode, we go hands-on. What does it actually look like to set up your first AI agent? We'll walk through the first steps, from install to your first conversation. In plain terms, no experience required. Episode 4 is coming. See you there. If you enjoyed this episode, please subscribe. It really helps us grow. And if you have a question about AI models or an idea for a topic you'd like us to cover, drop it in the comments. We read everything, and we just might make an episode for you. _ word count, approximately 1,870 words vertical bar. Estimated runtime, approximately 12 minutes at 155 WPM __. Research, WR brief delivered March 13, 2026. Fully incorporated _ pricing data. Intuition Labs LLM pricing comparison, February 2026. Plus official provider docs via WR _.